Lastly, in this set of videos, we're going to look at complex roots. As we said before, an nth degree polynomial has n roots. So quadratics have 2 roots, cubics have 3 roots, and so on. These include complex roots and repeated roots. So if we look at quadratics, then there are 3 possible solutions. We could have 2 real roots because the quadratic graph crosses our x-axis twice. We could have a repeated root where it just touches the x-axis, or we could have 2 complex roots because the graph doesn't cross the x-axis at all, and they would be a conjugate pair of roots. So we've already mentioned that roots of equations come as a conjugate pair. So if you know 1 plus I is a root, you know that 1 minus I is also a root. Cubic equations, we could have 3 real roots where the graph crosses the x-axis 3 times. We could have 1 root and then a repeated root here, so where it just touches it. We could have a repeated root that's a point of inflection, or we could have 1 real root and then 2 complex roots. Again, a conjugate pair. So equations with real coefficients means that the complex roots come as a conjugate pair, which is quite useful because if you know one of them, you automatically know the other. If we have a repeated root, then alpha is also a root of f dashed of x equals 0. It's to do with the gradient being 0. Sometimes we need to factorise to find the roots, so we will need to do something like polynomial division. Depends on which root you are given, or if you're given any roots. And then sometimes we can still use the connection between the coefficients of the equation and the roots. So this is an example of this just here. So if we had 7x cubed minus 8x squared plus 23x plus 30 equals 0, and that we've got the roots alpha, beta and gamma. A cubic equation, so we've got 3 roots. And the question asks us that if we've given that 1 plus 2i is a root, we need to find the other 2. Well, knowing 1 plus 2i is a root, we also know 1 minus 2i is a root, because they're the complex conjugates, and complex roots come in a conjugate pair. Now, we could factorise it and divide, but it's easier because we now know 2 of the roots to just use something like the sum of the roots being negative b over a. So the sum of the roots is 8, negative b, so 8 over 7. And if we look, if we add up the 2 roots, we've got 1 plus 2i plus 1 minus 2i plus this root that we don't know, our third root. We know that equals to 8 over 7. The imaginary part of the complex numbers cancel out, so we get gamma plus 2 is 8 over 7, which means that gamma must be negative 6 over 7. So our third root must be negative 6 over 7. So that's an easy way of finding the 3 roots.